Welcome Math All Day people. Today we're going to be continuing our work on relations. Specifically, we're going to be looking at the composition of relations. And if you've done any work with functions, you know that term composition and you know kind of some of the ideas that go along with composition. And so what I want you to do is I want you to be kind of thinking about composition of functions as we work with composition of relations, because functions are kinds of relations. And so the mechanism that happens when we compose two functions is very similar to the mechanism that we use when we compose two relations. So let's take a look at our definition for a composition. And we have two relations S and T on a set A. AC is in the composition S of T if and only if there is a B belonging to A and an AB belonging to T and a BC belonging to S. Now, a couple things that I want to point out here. One is that we have to have that intermediary step B belonging to A. It's got to be inside of the set A that we have both S and T on. Second, we notice that S and T are both going to be defined on the set A. Now, when we talk about functions, this kind of opens up or it kind of relaxes a little bit. But for our purposes here, we want to make sure that the set of vertices that we're looking at, the big set of vertices that we can work from for both S and T are in fact the same. Notice also that we'll start out at A, and that's going to be belonging to T, and we go from then A to B, and then we'll go from B to C, and B to C is in S. And that's important because our notation has it that we do T first. So all of our edges in T are going to occur first, and then our edges in S will come afterwards. So basically what we say is we say that we work inside out. We work T to S. So S of T means that T comes first and then S comes second. We might also talk about that as being from left to right. So basically in the opposite direction of what we read. Let's say, for example, we want to look here and find S of T. Now remember that we're going to go inside out. So we're going to start at T and then we're going to go over to S. Now, what you'll see is we'll start out with, say, for example, we start with A. So we go A to B, and then we're going to take a look over in S and we're going to see what comes out of B. So we'll go A to B. Right? And now we need to go B to whatever, but notice that there's nothing that goes from B outward. So consequently, in S of T for A, there's no edges that start with A. On the other hand, let's take a look at B. So now we go B to C. And when we come over and we look at S, we notice that C goes from C to B. So that means that our new edge is going to go B to B. Next up, we take a look, because there's only that one, B to C, C to B. We're going to look at C. So C goes to D. Great. So if C goes to D, we now need to figure out what D goes to. So D is now going to go to A. So we got C will then go to A inside of our new digraph, inside of our new relation. So C goes to A. But wait. So we've got that C goes to D. We also notice that D now actually has something coming off of it. It's got a self loop. So D goes to D. And now we're going to look at S and we see that D goes to A. So that means in our new relation, we're going to have that D goes to A. And that's S of T. S of T, if we were to rewrite it, this new relation is going to have B to B, C to A, and D to A. Once again, inside out. Notice here as well that we have nothing coming out of A any longer. And we have nothing going into C and nothing going into D. So things have actually changed pretty dramatically when we look at the composition of these two relations. Let's take a look at the same set of relations, but now let's switch the order. And we want to focus in now on the second example on how much order matters in terms of composition. So again, we've got A, B, C, and D. We'll start over here now, and we're going to start at S. So we notice that S has going from C to B. That's the first part of our composition. And now when we look at what comes out of B, all we have is we have that B goes to C. So consequently, our new edge is C to C. C to B, B to C, consequently C to C. Next up, we only have one more out edge, and that goes from D to A. So we got D to A, And we'll look at that. We've got D to A, and then we're going to go from A to B. And so consequently, that means that D goes to B. And you'll notice how different that is from the first composition that we did. Switching the order of those two compositions actually makes it so that we have a lot fewer edges, and those edges look fundamentally different. So now, what happens if I want to compose more than two relations? So in fact, I can compose as many relations as I want, and all we've got to do is we've really got to remember that that order matters, and that essentially we're doing kind of like this lily pad pattern. That is that the tail of one of the first goes to the head, and then that head becomes the tail, and then we go to a new tail, and then that tail becomes the head for the next set of edges. So let's say, for example, I want to do this, and what I want to do is I want a T of S of R. Now, what you'll notice here that I did is I made that R will come first, S comes second, and T comes third. Again, we're going to go from inside out. It's really important. And then I kind of structured my picture having R first, S second, T third. And that's just for instructional purposes. That's not necessarily going to be how it is all the time. So we'll start out at A, and in R, A goes to C and A goes to B. So now what I need to do is I need to move from R to S. So now I look at B and I see that B goes to B. Great. So I'm kind of thinking along these lines, and I'm going to kind of draw a little picture here. I've got A goes to B, A goes to C, and now, so A goes to B, A goes to C, and we'll see that in S, B goes to B, and we have B goes to D. And now we've got to move over to T, and we'll notice that in B goes to nowhere. There's no outs for B, and we'll see that D goes to C. So this is D goes to C. So this one actually here, we don't have any endpoint for that composition. So this is actually going to go away. We're not going to have that inside of our new composition. All we're going to have is we're going to have A going to C. So I got A goes to C. Next up, I'm going to look and I'm going to see, okay, well, what about B in R? So B goes to C. We'll see that that's the case. And so now I'll write that down, B going to C. And when I go into S, I now have C goes to C. And so that's one option. And then I also see that C goes to A. So I have both of those. So I have B goes to C, B goes to C, C goes to A. And now I'll go into T and I'll see what happens when I go to C. At C, I've got to go back out to B, right? That's this line right here. And then I'll see that at A is going to go to B. And I also have A going to C. So I have now B goes to C, goes to A, goes to C. So what you see now is you see I've got three values that are going to go from B. I'm going to have B going to B. I'll have a self loop instead of T of S of R. I'll have B going to B, beginning and end, B going to B. Again, that's another self loop. So we don't need to have that one twice. And then I'll have the third one, and that's going to be B goes to C. Now I'm going to move back to R because I finished all the ones that go off of B. Erase these just to kind of get them out of the way. And I'll see that C goes to B. So I have C goes to B. That's this line right here. And now C, in our next one, B will also go to B again. So B goes to B because we have the self loop there. And we have B going to D. So C goes to B, goes to D. That's another one. Now I'm going to move over to T, and we're going to see that D, we'll look at the bottom one here, we'll have D go to C, and we'll go to B, and we'll see that B, well, nothing comes off of B, so this one here, this kind of ends, we're not going to do anything with that. So now what we get is we get a self loop coming out of C, going back to C, and that's the only thing that's coming out of C. Finally, we're going to take a look at D, and we're going to notice that D goes to D. That's going to be a self loop there. So we have D goes to D in R. Then we're going to see that in S, what goes to D is going to go to C. So D goes to D goes to C. And then finally, we'll go over to C, go over to T, and we're going to go to C, and we'll notice that C goes to B. And C doesn't go to anything else other than B, so we get D going to B being our only out coming out of B. So D goes to B. So our new digraph for T of S of R is going to look like this. If we were to draw the set, what we get is we get AC, BB, CC, BC, and DB. And there's our digraph. Once again, we're going to start on the inside, and then we're going to move one relation at a time, one edge at a time, from inside out. Now, digraphs are great for visualizing relations. And we know that there's a one-to-one correspondence between a digraph and its relation. However, if you're working with computers, or you want to actually do this analytically, or you really kind of understand how it works, how that whole process of composition works, frequently what you're going to want to do is you're going to want to kind of imagine what would happen if you construct compositions from sets of edges without drawing the digraph. And it's a pretty easy process, although you have to be really careful and really meticulous, or else you make a lot of mistakes. So let's say, for example, we want to do S of R. So we look at R, and what we want to do is we're saying, okay, I start with A, and we're going to go A to B, and now I want to look down at S and see, are there anything that start with, that have as their tail B? And we notice that there are none that have the tail as B, and so consequently, or excuse me, that have the head as B, and so consequently, we don't have anything for this first edge, A to B. What about B to A? Well, now we got B to A, we notice, all right, well, I'm going to start with B, and we're going to see in S what comes out of A. Well, B goes to A goes to B, so that's B to B. So there's our tail at A, it's our head on A in S, and so consequently we get B to B. We'll now go to A to C, we look at AC, and we want to look at C and S, so we see A goes to A, and A goes to D. So we'll put those in. Next up, we're going to look at B. So we see that B goes to D, and we look in S, there are no D's, so consequently there's nothing going to be coming off of that particular edge. Finally, we'll look at D. We got D goes to B, and again, there's nothing coming off of B inside of S, so this is the full set of edges inside of our new relation. That is our new relation, in fact. What if we switched our order and went from R to S? So now we start in S, and we see, okay, I've got AB, and now I want to look at anything that begins with B, that has B as its head, and we got B to A, so that means we get AA, right? We take the head of the one in S and the tail of the one in R, and that becomes our new edge or relation. Are there any others? Nope, no others that actually, oh wait, we do have one here, B to D, so that means that we're going to go from A to D. And those complete all our B's. What about starting here, CA? Now we look, we got CA. We'll go C to B. Okay. So that's going to be in our new composition. Then we'll go CAAC. So we'll get that self loop of C to C. Any others with A? No others with A. Now we're going to go to this third one and ask, we got C to D. So we look at what things begin with D, have D as the head, and R, only this last edge. So that means we're going to go C to B. And that's the new set of edges in our relation. So what you can see is this can actually kind of like save you a lot of time, and also from the perspective of, say, for example, that you're programming something or you want to think about something in terms of a program, you're probably going to want to be doing things this way. That is where you're searching for heads in one of the relations and tails inside of the other, and then putting them together, basically eliminating the middle portions. So composition reads from right to left or inside out. So what this means is that S of T is going to start with edges in T and end with edges in S. T of S will start with edges in S and end with edges in T. We want to remember also that the set of edges for a composition can and will change depending on the relationships between the edges in each individual relation and the order in which we compose them. So if we're composing in different orders, we actually end up with a new relation. And that S of T and T of S, they are in fact their own relations. They're not just some kind of like relationship between S and T. They are a relation in and of themselves. And thirdly, you don't need to draw a digraph to compose two relations. However, if you're going to do this, trust me, you want to be patient and be thorough when you're composing by hand in order to avoid making any mistakes. Computers do this stuff really, really easily, really well, because they do things that are kind of rote and redundant quite well. We don't. But if you're going to do it yourself and do it by hand, just be careful, be patient. That ends our talk on the composition of relations. If you liked this video, please go ahead and click the like button. And if you like the work that I'm doing and you want to subscribe, go ahead and subscribe. There's a whole playlist on relations.